Let's take a look. The first question, 1.1.1, we have 3x squared plus 5x being equals to 0. We needed to solve for x for 2 marks. It's quite obvious what we need to do in this question. We need to take x as a common factor. If we do that, we're going to have x multiplied by 3x plus 5 being equals to 0. Right. So if we are multiplying these two numbers, x or 3x plus 5, and the product is 0, it's either x is equals to 0 or 3x plus 5 is equals to 0. That is the only way you can multiply two numbers and get 0. One between the two numbers has to actually be equals to 0. So on the right hand side, we're going to then have 3x being equals to minus 5. So x is equals to minus 5 divided by 3. These two answers will be true for 3x squared plus 5x is equals to 0. So that is the first question, 1.1.1. Let's go ahead and take a look at 1.1.2, where we have 4x squared plus 3x minus 5 being equals to 0. The question says, let's round off our answers to correct to 2 decimal places. When the question says that, we know that we are about to use the quadratic formula. So let's go ahead and do that. 4 is A, 3 is B, and minus 5 is C in our general formula. So we're going to have x being equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a. We are going to have x being equals to minus b plus or we're going to have x being equals to minus b. B is 3 plus or minus the square root of b squared. So b is 3, we have 3 squared minus 4. A is 4 and c is minus 5. Everything divided by 2a. A is 4 once more. So x is equals to, we just need to substitute that in our calculator. We're going to get x is equals to 0.8 or x is equals to. So I just need to substitute to change the plus sign with the minus sign. When I do that, I get minus 1.55. So there we go. These are our two values of x. I'm getting minus 0.04. So I'm convinced that my answers are correct. I'll round it off, so I'm not gonna get exactly 0. But then if it is very close to 0, I'm gonna be convinced that whatever I did was correct. That is 1.1.2. Let's take a look at 1.1.3. We have x minus 1 squared minus 9 being greater or equals to 0. So let's go ahead and find our critical values from the get-go. If we do that, we're going to have x minus 1 squared minus 9 being greater or equals to 0. Well, when we find in our critical values, we will let these be equals to 0. Right. So x minus 1 squared, that is x squared minus 2x plus 1 minus 9 being equals to 0. So we have x squared minus 2x minus 8 being equals to 0. So let's factorize this. 2 factors of minus 8, of which when we multiply, we get minus 8 obviously. And then when we add, we get minus 2. That is minus 4 and plus 2. And these are equals to 0. So it's either x is equals to 4 or x is equals to minus 2. So these are our critical values. So we now have 2 possible solutions to this problem. It's either x lies between minus 2 and positive 4, or x is less or equals to 2, or x is equals to or greater than 4. These are our 2 possible solutions. We need to test these solutions and see which one is true. So let's take a look at this solution which we're proposing. X is between minus 2 and 4. So 0 is between minus 2 and 4. So we can substitute 0 in our equation and see if our inequality is going to be satisfied. So let's go ahead and do that. We're going to have x minus 1 squared minus 9 being greater or equals to 0. So let's substitute 0 and see what happens. We're going to have 0 minus 1 squared minus 9 being greater or equals to 0. So minus 1 squared is 1. 1 minus 9 is greater than 0. So minus 8 is greater than 0. Well, we know that this is not true. Minus 8 is not greater or equals to 0. So this is our solution. This is our solution, and this is wrong. Right? So we can actually conclude and move to the following question. All right. Other people use other techniques, and that is totally fine. But at the end of the day, it's either x is less or equals to 2 or x is greater than 5. We can try x is greater than or greater or equals to 4 by substituting 5. If we substitute 5, we get 5 minus 1 squared minus 9 is greater or equals to 0. 5 minus 1 squared, that is 4 squared, which is 16 minus 9, greater or equals to 0. And this is true. So we are quite convinced that our conclusion for 1.1.3 is correct. Now let's take a look at 1.1.4. In 1.1.4, we have 5 to the 2x minus 5 to the x being equals to 0. This one seems easy to solve. Let's take a look at the mark allocation. The mark allocation is 4. I don't see why that is the case. Right. Okay, let's do this. So we can let 5 to the power x be equals to k, or we can just take 5x to the other side and solve for x. Let's do both. Right. If we do that, we're going to have, so 5 to the power x is equals to k. Right. So we're going to have k squared minus k being equals to 0. So k as a common factor, we're going to be left with k minus 1 being equals to 0. So k is equals to 0 or k is equals to 1. Right. These are our two options that we have. Now let's do it with the other way. The other way that I'm proposing, we say 5 to the power 2x is equals to 5 to the power x. We just take in minus 5 to the power x to the right hand side. We have the same basis, so we can equate the exponents. So we're going to have 2x being equals to x. So 2x minus x is equals to 0. X multiplied by 2 minus 1 is equals to 0. So x is equals to 0. Right, when we use this way, we only get x is equals to 0. So let's go ahead and take a look and see what makes sense. Right, if x is 0, we have 5 to the power 0 minus 5 to the power 0, which is going to be 0. 1 minus 1 is 0. And then if we substitute k is equals to 1, we're going to have 5 to the power 2 minus 5. And 5 to the power 2 is 25. So we have 25 minus 5, which is 20 and not 0. So this seems to not work. So let's go ahead and apply this idea instead. This is correct. X is equals to 0 is part of our solution. Maybe let's see why k cannot be equals to 1. Let's see why k cannot be equals to 1. So here we have k squared minus k, which is equals to 0. We take k as a common factor. We have k minus k. If we multiply out, we go back there. And then k is equals to 0, or k minus 1 is equals to 0. When you take k to the other side, we get k is equals to 1. Right, I see where the issue is. Let me show you. Right, I missed something there. So we are saying that k is equals to 0. But we know that 5 to the power x is equals to k. So 5 to the power x, we are saying that it is equals to 0. And these cannot be true. That can't be true. If we have 5 to the power any number, it cannot give you 0 no matter what. So 5 to the power x is the one that is equals to 1. For this to be true, we need 5 to the power x to be equals to 5 to the power 0. So x is equals to 0. This is correct. This cannot be true because 5 to the power, well, this is true. This is what is true. K is equals to 1. This cannot be true because 5 to the power x cannot be equals to 0. So there we go. We have solved 1.1.4. Let's take a look at 1.1.5. we have x divided by 20 minus x. This is equals to 1. If we cross multiply, we're going to get the square root of 20 minus x being equals to x. So squaring both sides, we get 20 minus x being equals to x squared. So we're going to have x squared plus x minus 20 being equals to 0. So let's solve. We are factorizing two factors of minus 20, of which when we add, we get plus 1. Plus 1 is the coefficient of x. So what are those two factors? Plus 5 and minus 4. So x plus 5, x minus 4. X is equals to 5, or x is equals to, or x is equals to 1, or x equals to minus 5. I'm making a mistake here. X is equals to minus 5, or x is equals to positive 4. When we substitute minus 5, we get a minus 5 divided by the square root of minus x. So minus multiplied by minus, we get 25. These cannot be equals to 1. So x cannot be equals to minus 5. X cannot be equals to minus 5. This is not correct. Let's check 4 and see if it is correct. If we substitute 4, we get 4 divided by the square root of 20 minus 4. So this is 4 over square root of 16, which is equals to 1. So x equals to 4 is correct. X cannot be equals to minus 5. So that is 1.1.1 to 1.1.5. Let's do 1.2 and 1.3 on a separate video. See you soon. In this video, the focus is on 1.2 and 1.3. We have actually solved 1.1.1 to 1.1.5 on a separate video. So let's go ahead and do 1.2 together. We're supposed to solve for x and y simultaneously, so that shouldn't be too difficult. Let's take a look at that. We have x plus y being equals to 9 and 2x squared minus y squared being equals to 7. So we can either let x be the subject of the formula here, or let y be the subject of the formula. Rather, let's let y be the subject of the formula. We're going to have y being equals to 9 minus x, of which when we substitute here, we're going to get 2 multiplied by x squared minus y squared. But we are saying that y is equals to 9 minus x squared. This is equals to 7. So 2x squared minus. So what is 9 multiplied by 9? That is 81. 9 multiplied by minus x. You multiply that by 2, you get minus 18x. And then minus x multiplied by minus x. That is plus x squared. This is all equals to 7. So we're going to have 2x squared minus x. So that is x squared. And then minus, well, plus 18x when you take it out of the bracket. And then minus 81. We take 7 to the left-hand side. We get minus 7. This is all equals to 0. So we have x squared plus 18x minus 88 being equals to 0. So let's go ahead and see if we can actually factorize that. Two numbers, when we multiply, we get minus 88. When we add them, we get plus 18. We are getting x plus 22, x minus 4. If we add them, we're going to get minus 18. If we multiply them, we get minus 88. So that seems to work out. So x is equals to minus 22, or x is equals to 4. Right. So what is y equals to when x is equals to minus 22? We're going to have 9 minus x. X is minus 22 in this case. So that is 9 plus 22, which is 31. Right. Y is equals to 9 minus x. And in this case, x is 4. So what is 9 minus 4? That is 5. So there we go. These are our answers. X is equals to 22. X is equals to 4. X is equals to 31. Y is equals to 31, and then y is equals to 5. That is 1.3. We're just solving simultaneously. That shouldn't be too difficult. And now the question you've been waiting for, 1.3. We have an interesting case. P is equals to 1 minus a, and we have some t which is equals to 1 plus a multiplied by 1 plus a squared, 1 plus a to the 4 up until 1 plus a to the 512. So we want to determine the value of p multiplied by t in terms of a. Right, so what is p? P is 1 minus a. What is t? T is 1 plus a. So multiplication is commutative, so we don't care about the order really. Multiplied by 1 plus a squared multiplied by 1 plus a to the 4 up until 1 plus a to the 512. So let's take a look at this. What is 1 minus a multiplied by 1 plus a? That is the difference of two squares. So that will give us 1 minus a squared. So now this boils down to 1 minus a squared. And then we are left with 1 plus a squared multiplied by 1 plus a to the 4 up until 1 plus a to the 512. Again, let's take a look at this. 1 minus a squared multiplied by 1 plus a squared. Difference of two squares once more. So we have 1 minus a to the 4. That is the square. Right. And then multiply by 1 plus a to the 4 up until 1 plus a to the 512. So this is gonna go on up until we have 1 minus a to the 512 multiplied by 1 plus a to the 512. This is again a difference of two squares, of which we can just write it as 1 minus a to the power 512 multiplied by 2, which is 1024. So this is p multiplied by t in terms of a. 1 minus a to the 1024. There we go. Which video do you want me to do next? Drop a comment. Should we go to question 2, 3, 4, or should we go to question 9? Let me know right now in the comments. See you in the next video. Let's just go ahead and do 2.1.1. So consider the geometric series 4 plus 2 plus 1 plus and a half. Does the series converge? Justify your answer. So what is the prerequisite for a series to converge? We need r to be between 1 and minus 1. When this is the case, our series is converging. And when that is not the case, it is divergent. So let's go ahead and see if it is going to be converging or diverging. We have r being equals to t2 divided by t1. That is r in a geometric series. So t2 we can take 2 and t1 we can take 4. Obviously 2 divided by 4, that is a half. A half lies between minus 1 and 1. So indeed this series converge. So it converges because r is equals to a half, which is between minus 1 and positive 1. So there we go. We have answered 2.1.1. What about 2.1.2? Let's take a look at that. 2.1.2, calculate S infinity, the sum to infinity. If it is converging, we can calculate the sum to infinity. So 2.1.2 actually tells you the answer to 2.1.1, or it hints at the answer. It is telling you that this series is convergent because we can only calculate the sum to infinity if it is convergent. Anyway, sum to infinity, a divided by 1 minus r. So a is the first term, which is 4, divided by 1 minus r. R is a half. So 4 divided by half, this is equals to 8. So the sum to infinity of this geometric series is 8. 2.2. So 2.2, we're given some sigma notation, right? And we're supposed to calculate the value of k. So let's take a look. We have this sigma notation running from p is equals to k to 10. where the formula is 3 to the power p minus 1, and this is all equals to 29,520. So let's take a look. The first term is going to be 3k minus 1. The second term is going to be whatever it is. We can't really say because we don't have the value of k, but the last term is going to be 3 to the power 10. And if we add those terms, we get 29,520. What we can deduce from this is a, the first term. The first term is equals to 3 to the power k minus 1. And another thing we can figure out is r, the common ratio, because this is geometric. The common ratio is going to be 3. R is equals to 3. That is the common ratio, right? Because we know that a geometric series is in the form AR n minus 1. A seems to be 1 in our equation, R is 3, and then n minus 1, that is p minus 1 in our case. So we have A and we have R, and we have the sum of the 10 terms, right? Or not the 10 terms, let me not say that. We have the sum up to k terms. Not up to k terms, but from k to 10. We don't know the number of terms actually. And this is equals to 29,520. So we can formally say that the sum of n terms is equals to a multiplied by r to the n minus 1, everything divided by r minus 1. We have the sum, we have a, do we have n? Let's calculate n then. N is equals to the number at the top, so 10 minus the number at the bottom, which is k, plus 1. This is the number of terms. So this will boil down to 11 minus k. So there we go. This is the value of n, the number of terms. Let's go ahead and finally substitute. We're going to have 29,520 being equals to a. A is the first term, so this is 3k minus 1 multiplied by r to the power n. R is 3 and n is 11 minus k minus 1, everything divided by n minus 1. R minus 1, I mean r is 3, so we have 3 minus 1. 3 minus 1 is 2, so if we cross multiply, we have 29,520 multiplied by 2. So this is 59,040 being equals to 3k minus 1 multiplied by 3, 11 minus k minus 1. So let's multiply these by k and this, not by k, but by 3 to the power k minus 1. So 59,040 will be equals to, so 3, if we multiply numbers of the same base, we add the exponents. Let's just add it on the side. K minus 1 plus 11 minus k. K minus k, 0 minus 11 plus minus 1 plus 11, that is 10. So we actually have 3 to the power 10 minus 3k minus 1. So let's take 3 to the power 10 to the left hand side. We're going to have 59,040 minus 3 to the power 10 being equals to minus 3k to the minus 1. So 59,040 minus 3 to the power 10. 59,040 minus 3 to the power 10. I'm getting minus 9 being equals to minus 3k to the minus 1. So dividing both sides by minus 1, 9 is equals to 3k minus 1. We want to drop the bases and equate the exponents. So let's write 9 as 3 to the power 2 is equals to 3k minus 1. So 2 is equals to k minus 1. 3 is equals to k. There we go. Which video do you want me to do next? Let me know in the comments right now. I don't know if it's because I missed some of my classes in high school and university, but 3.1.2 doesn't make any sense to me. Let's go ahead and take a look and see what I'm talking about. We need to start with 3.1.1 first. So let's go ahead and do that. We are given a quadratic number pattern with the first three terms being 3, 7, and 12. We're supposed to find the general term. Actually, show that it is equals to what we have there. So we need to find the second and common difference, right? So 7 minus 3, that is 4. 12 minus 7, that is 5. 5 minus 4 is 1. So a, not a, but 2a rather. 2a is equals to 1. And 3a plus b is equals to 4. And then a plus b plus c is equals to 3. This is not coming from nowhere. We have actually proved why this is the case. You can go ahead and watch a video on me proving why 2a is equals to the second common difference. But let's solve the question at hand. 2a is equals to 1, so a should be equals to half, right? And then 3a plus b is equals to 4. So 3, we know now that a is a half, plus b is equals to 4. So we have b being equals to 4 minus 1.5, which will be 2.5. 2.5 is 5 over 2. So we have b. Let's go to c. A plus b plus c is all equals to 3. A is a half and b is 2.5 plus c is equals to 3. It should be easy to see that c is equals to 0. 3 minus 2.5 minus 0.5 will give you 0. So we have tn being equals to an squared plus bn plus c. A is a half, and then b is 5 over 2, and c is 0. So this is what we have. That is the general term. Alright, nothing complicated there. Sticking to the basics, we are very familiar to questions like this. Now let's take a look at 3.1.2. Right, so 3.1.2 on the other hand, what number must be added to tn minus 1 so that tn is equals to 1,000, not 1,000, but 13,527. What number must be added to tn minus 1 so that tn is equals to 13,527? Just leave a comment. Explain to me what this question is asking. I don't understand. I cannot figure out what this question wants us to do. What number must be added to tn minus 1 so that tn is equals to 13,527? I was supposed to find the value of n for which tn is going to be 13,527. But if that is the case, what's the need of saying what number must be added to tn minus 1? I was supposed to find which value of n gives us 13,527 and then calculate tn minus 1 and find the difference between the two. I'm not quite sure. I can't seem to figure out what this question wants us to do. I've never came across a question like this ever before. But let's just go ahead and do the second idea. Tn is equals to 13,527. In place of tn, we know that we have a half n squared plus 5 over 2n being equals to 13,527. So if we take 13,527 to the left hand side, we get a half n squared plus 5 over 2n minus 13,527 being equals to 0. We can multiply everything by 2 to get rid of the denominators on the coefficient of n squared and n. If we do that, n squared plus 5n minus, okay, let me put that in my calculator, 13,527 multiplied by 2. That is 27,054. This is all equals to 0. Right, I need to use the quadratic formula now because I can't factorize this with my hand. So n is equals to minus b plus or minus the square root of b squared, so that is 5 squared minus 4ac. A is 1, c is minus 27,054. Alright, everything divided by 2a. A is 1. So let me go ahead and put this in my calculator. Minus 5 plus 5 squared minus 4. A is 1. C is minus 27,054 divided by 2 multiplied by 1. So n is equals to 162, or n is equals to. So let me replace the plus with a minus sign, and I get minus 167. So obviously position cannot be negative, so n is equals to 162. So T162 is equals to 13,527. Let me verify and see if I'm not making a mistake. I'm going to substitute 162 into 3n. So a half multiplied by 162 squared plus 5 over 2 multiplied by 162. Yeah, it comes back. I'm getting 13,527. So T162 is 13,527. But I'm not quite sure that's what the question wants me to find. Let me just calculate T161, because T161 is actually Tn minus 1, because now we know that n is 162. So I'm just replacing 162 with 161. Let me do that and see what I get. I'm getting 13,363. So let me say T162 minus T161 and see what I have. 13,527 minus 13,363. Right. So it's 527 minus 363. I'm getting 164. Is this what we are supposed to determine? I'm not quite sure. Leave a comment. Let me know how you solve this question. Let me know what you're thinking. What does this question want us to do? This question 4 is probably the easiest I've seen in a long time. Let's go ahead and take a look at it and see what we can do. First question, 4.1, write down the equations of the asymptotes of g of x. So we have g of x being equals to 1 divided by x minus 1 plus 2. So in order to find our asymptotes, let's start with the vertical asymptote. So vertical asymptote, we need to equate this denominator to 0, because you cannot divide by 0. So that value of x will be our asymptote. So x minus 1 is equals to 0. X is equals to 1. That is our vertical asymptote. And now our vertical, not our vertical, but our horizontal asymptote will be y is equals to 2, because we know that the graph cannot touch 2. So horizontal asymptote, y is equals to 2. There we go. X is equals to 1 and y is equals to 2 are our asymptotes. 4.1. Let's take a look at 4.2. 4.2, draw a graph of g indicating any intercepts with the axis and asymptotes. Okay, we need to draw this graph. We already have the asymptotes, we just need the intercepts now. Let's start with the y-intercept. So y-intercept, we know that x is equals to 0. So we're going to have g of 0 being equals to 1 divided by 0 minus 1 plus 2. So 1 divided by minus 1, that is minus 1, plus 2 is positive 1. So our y-intercept is some coordinate, x is 0 and y is 1. Okay, let's move to the x-intercept, where now y is equals to 0. So we get 0 is equals to 1 divided by x minus 1 plus 2. We take 2 to the left hand side, minus 2 is equals to 1 divided by x minus 1. If we cross multiply, we're going to get minus 2x plus 2 is equals to 1. So minus 2x is equals to 1 minus 2, which is minus 1. So x is equals to a half. Our x-intercept, x is a half, and obviously y is 0. So we have our intercepts and our asymptotes. We can go ahead and sketch this graph. So let's go ahead and do that. So these are our axes. We have the y-axis and we have the x-axis, we now need to indicate our asymptotes. We have one asymptote at y is equals to 2. So y is equals to 2 somewhere here. And then we have the asymptote, the other asymptote. Let me check. X is equals to 1. So somewhere here we have the other asymptote. So there we go. We have our asymptotes. Now we need to sketch our graph. Well, we just need to locate our intercepts, and we're gonna see how our graph should look like. So the intercepts, we have 0 and 1 for the y-intercept. So 1, y is equals to 1 is somewhere here, right? Because our asymptote is at y is equals to 2. And then we have x is equals to a half. So a half should be somewhere here. That is all we need actually, because now we can sketch our parabola and it should look something like this, right? The graph should curve, it should not be straight. Some people, they write it like this, which is totally wrong. So this is what we are supposed to have. Let me make this, let me give this another try. Yeah, that we're supposed to have. It doesn't look too clean. It doesn't look too clean. Let me rework it again. Yeah, so there we go. We have our graph. Let's just indicate the points of interest. Here we have a half and 0, and here we have 0 and 1, and here we have the intersection of our asymptotes. It's not a coordinate because the graph doesn't touch there, so let's just leave that point. Let me not use arrows here, because now it's like I'm drawing a graph. Let me not do that. Let me just bring the point closer instead of doing that, right? I don't want any issues to arise. I don't want to lose any marks. Yeah. So a half, 0, and this is 0 and 1. That is way much better. If I put an arrow there, it seems like it's a graph, and that is unacceptable. 4.2. What about 4.3? What about 4.3? Yeah, we do need to show here that our x's, they keep going, right? And then this is the y, and this is the x. Because if I don't see that on your script, then assuming it's not a graph, you were just putting some lines and you didn't answer the question. I must see the x's. Right, 4.3, determine the values of x for which g of x is greater than 0. So let's stick to our sketch here. We can see that in this part, g of x is greater than 0. We can clearly see that. And then another part where g of x is greater than 0 is this part. From x is equals to a half, this part, up to negative infinity. G of x is greater than 0. So what are we saying? We're saying that when x is greater than 1, g of x is greater than 0. Because x cannot be equals to 1, that's our asymptote. And x is less than a half. G of x is greater than 0. So that is our solution. From the graph, I think you can also solve this algebraically and find the same value. Okay, 4.4. Determine the equation of the axis of symmetry of G, which has a negative gradient. Right, so the one that has a negative gradient is minus x plus c. If it had a positive gradient, it would be y is equals to x plus c. That's how it works. And then the point you substitute here is where your asymptotes intersect. Our asymptote, x is equals to 1 and y is equals to 2. This is the point we need to substitute in order to find this c on the axis of symmetry. Okay, of which when we do that, 2 is equals to minus 1 plus c. So 3 is equals to c. Y is equals to minus x plus 3. There we go. Which video do you want me to do next? Leave a comment and I'll do it right now. Write down the coordinates of P prime, the image of P on G. Let's go ahead and take a look and see what is happening. So in the diagram, the graphs of f of x is equals to log of x base a and g are drawn. Graph G is the reflection of f in the line y is equals to x. We need to make sense of that. The graph of g is the reflection of f in the line y is equals to x. So f of x is equals to log of x base a, and then g is a reflection of f in the line y is equals to x. So for g, we have x being equals to log of y base a. So g is the inverse of f. We need to deduce that first before we can answer the other questions. Graph f passes through the point P of coordinates 2 and 4. We can clearly see that. And then Q is the x-intercept of f and r is the y-intercept of g. All right, let's go ahead and do 5.1. So 5.1, write down the coordinates of P prime, the image of P on G. So what an inverse does is that instead of having coordinates, we know that for P we have x, y. So because G is the inverse of f, for P prime we're gonna have y, x, right? So what is P? P has coordinates 4 and 2. And then for P prime, we're gonna have coordinates 2 and 4. That's what an inverse does to an equation. There we go. That is 5.1. Let's take a look at 5.2. 5.2 says that let's show that a is equals to 2. We have f of x being equals to log of x base a. We want to show that x is equals to 2. How can we do that? You can substitute any point on f, right? We have p of coordinates 4 and 2. So let's substitute p. In substituting p, the y value is 2 and the x value is 4. And then we have a as our base. If we apply a log law, we're going to have a to the power 2 being equals to 4. We can always do that when we have log. And then a to the power 2 will be equals to 2 to the power 2. We drop the exponents. A is equals to 2. So there we go. We have shown fully well that a is equals to 2. 5.3 on the other hand, let's take a look at 5.3. Write down the equation of g in the form y is equals to. Like I've said, g is the inverse of f of x. So f of x is equals to, now that we know that a is equals to 2, we're going to have x and then the base is 2. So in order to find g of x, we need to swap x and y and solve for y. So the first step, swap x and y. So in place of y, we put x. And then in place of x, we put y. And then a is 2, I'm forgetting. And then now it's just a matter of solving for y. Obviously, the 2 is going to carry the x. We're going to have y being equals to 2 to the power x. And there we go. We have the equation of g of x. That is 5.3. 5.4, quite an interesting question. Let's take a look. T is a point on f in the first quadrant, right? Where TR is parallel to the x-axis. T is somewhere here. T is somewhere there. Let me just join the 2 points. That is where T is located because we need TR to be parallel to the x-axis. So T is somewhere here. And then let's hear the stories. Calculate the area of triangle RTP. We want the area of triangle RTP. P the inverse, right? Or P prime, the one we get when we reflect P on y is equals to x. Right, so let's see how we can possibly calculate that area. Let's zoom in here. So T, if it is parallel to the x-axis, if TR is parallel to the x-axis, then we know fully well that R and T, they have the same y value. But what is the y value of R? We know that R is the y-intercept of G. So G of x is equals to 2 to the power x. We are saying that R is the y-intercept of G. So y-intercept, will let x be equals to 0. 2 to the power 0 is 1. So the y-coordinate of R is 1 and the x-coordinate is 0. So here for R, we have, let me just make my pen a bit lighter. we have 0 for the x value and 1 for the y value. And then now let's come to t. When we come to t, the y value is the same. We still have 1. That is our y value because tr is parallel to the y-axis. What we don't have is the x value of t, but we can calculate it because it lies on f of x. Let's go ahead and do that. F of x is equals to log of x base 2. We know that the y value is 1, so let's go ahead and determine the value of x at t. So log of x base 2. 2 carries 1, so 2 to the power 1 is equals to x. So that right, the x value at t is 2. We have 2 as for the x value at t. Now let's go back to our point p prime. P prime. We have coordinates 2 and 4. We came up with that in 5.1. So the x value is 2. So it is somewhere, it lies on G. So it is somewhere here, right? And then the x value is 2 and the y value is 4. Right. So let's join these 3 points so that we can calculate the area. There we go. We have joined the 3 points. Obviously, here we're going to have an angle of 90 degrees. TR is parallel to the x-axis, and TP, we have T here, and here we have P. And the TP will be parallel to the y-axis because they share the same x value, T and P. So in order to calculate the area of this triangle RTP, we're going to have a half base multiplied by the height. Base is TR, right? T and R, they share the same y value. So in order to find that length, we can just subtract or find the difference between the x values, right? The x value at T is 2, the x value at R is 0. So we have 2 as our base. And now our height, T and P, they share the same x value. So in order to find the distance from T to P, we just subtract the y values, which is 4 minus 1. So that is 3. So 2 multiplied by 3 is 6, multiply that by half is 3. So we have 3 units squared. Write down the range of f. F is given by f of x is equals to x squared minus 2x minus 3. And we're given the sketch right here in front of us. And then we have the coordinates of t, which is the turning point of f of x. The coordinates of t, it's 1 and minus 4. As you can clearly see, f of x, it cannot be below minus 4, as minus 4 is its minimum point, right? So the range for f of x, 6.1, y is greater or equals to minus 4. Y cannot be less than minus 4, as you can clearly see from the sketch, right? And then 6.2, calculate the coordinates of D and E. What are the coordinates D and E? What's special about those coordinates? They are said to be the x-intercepts of f. So x-intercept, we know fully well that we are letting y be equals to 0. So we're going to have x squared minus 2x minus 3 being equals to 0. So x and x. Which two factors of minus 3 do we add and get minus 2? That is minus 3 and plus 1. So x is equals to 3 or x is equals to minus 1. The question said the coordinates of D and E. So if you leave it like this, we are losing some marks. D, we have negative 1 and 0. While on the other hand, we have E. E is 3 for the x value and 0 for the y value. So there you go. We have the coordinates of D and E. Let's take a look at 6.3. So 6.3, write down the equation of G, or determine, not write it down. Right, the equation of G. So G touches f of x at P and E. Right, G of x and f of x, they intersect at P and E. G of x is a straight line, so g of x is equals to mx plus c. We need the gradient and just one other coordinate to substitute and find the value of c. Let's determine the values of p and the values of e. If we determine the value of p and the value of e, the coordinates rather, we will be able to say y2 minus y1 divided by x2 minus x1. So let's do that. The coordinates of e, we already have the coordinates of e, that is 3 and 0. We just need the coordinates of p. What is special about p? P is the y-intercept of f, is given to us in the equation statement. So y-intercept, we just let xb equals to 0. So if we do that, we get y being equals to 0 squared minus 2 multiplied by 0 minus 3. This is equals to minus 3, obviously. So the coordinates of p, we have 0 and minus 3. So there we go. We have p and e. Let's go ahead and find the gradient. The gradient, y2 minus y1 divided by x2 minus x1. I keep on writing x1 here in place of y1. I don't know why that is so. Okay, let's take e as our second point. If we take e as our second point, then y2 will be 0 and y1 will be minus 3 divided by x2 at e, that is 3, at p, that is 0. So we have 3 actually on the numerator. So 3 divided by 3, that is 1. So at this point, we know that, I don't think that's going to fit. At this point, we know that g of x is equals to x plus c. Yeah, because the gradient is 1. And then now we can go ahead and substitute e or p. Let's substitute e because the values are positive. We are less likely to make a mistake there. If we do that, we're going to have y value is 0, x value is 3 plus c. So minus 3 is equals to c. So g of x is equals to x minus 3. There we go. That is 6.3. Let's take a look at 6.4. So 6.4, on the other hand, write down the coordinates of x for which f of x minus g of x is greater than 0. Well, you can answer this question as it is, or you can just write it as f of x is greater than g of x. We're just taking g of x to the right hand side. So now we're just looking for values of x for which the graph of f of x is above the graph of g of x, right? So let's see, from this point up to infinity, f of x is above g of x, and from this point up to negative infinity, f of x is above g of x. F of x is below g of x between p and e, but apart from that, f of x will be above g of x, right? So what are those x value? When x is greater than 3, f of x is greater than g of x. That is the x value of e. And then when x is less than 0, not minus. When x is less than 0, then also f of x will be greater than g of x. That is all we need to do for that question. 6.4. Let's move to 6.5. I've been corrected by one of the viewers about 6.5. So this is actually the second version of this video and not the first one. So in 6.5, we wanted the maximum vertical distance between h and g, not h and f, like I initially solved the problem. So we know that g of x is equals to x minus 3. We determine that above, right? And then h of x, on the other hand, it is equals to minus f of x. We just need to substitute f of x here. F of x is x squared minus 2x minus 3. So we have minus x squared plus 2x plus 3. This is h of x and this is g of x. We want to determine the maximum vertical distance between these two. H of x is going to look like this. That is how h of x is going to look like. So clearly we have h of x being above g of x. When that is the case, the distance is going to be h of x minus g of x. So that is what we are working with. H of x, we know that it is minus x squared plus 2x plus 3. And then the g of x, that is x minus 3. So we're going to have minus x squared, 2x minus x, that is plus x, and then 3 minus 3, that is going to be plus 6. So we have plus 6. So this is the distance we are working with here, right? So in order to find the maximum, we need to either derivate this and equate to 0 or find the x value of the turning point. The x value at the turning point is minus b divided by 2a. Minus b is 1, the coefficient of x, and a is minus 1. So we have x being equals to minus 1 divided by minus 2. That is 1 over 2. So x is equals to a half. So now we can go ahead and find the distance. The distance is going to be minus, and then in place of x we have a half squared plus a half plus 6. Let me just put that in my calculator. So minus a half squared plus a half in place of x plus 6. This is 6.25 or 25 over 4. 25 over 4 units. Right, let's see if we substituted correctly. I think I did. So there we go. That is the maximum vertical distance between h and g, and not between h and f of x. The last question, let's take a look at that. Given that k of x is equals to g of x minus n, determine n if k is a tangent to f. Determine n if k is a tangent to f. Right, k of x is equals to g of x minus n. So let's substitute g of x first here and see what we have. G of x, we know that it is x minus 3. We calculated it before. Minus n. So k of x is x minus 3 minus n. So determine n if k is a tangent to f. Right. So the gradient here, take a look at this. The gradient of k of x is equals to 1. So the gradient here is equals to 1. So what we can do, we can derivate f of x and equate the gradient to 1, and then find the x value where f of x is equals to, where f prime of x, the gradient is 1. With that x value, we can then substitute it into f of x to find a point that lies on k of x. Let me show you what I'm proposing. I'm saying that f prime of x is equals to 2x minus 2. If we equate this to 1, the gradient of k of x, we're going to find a point that lies on k of x. So 2x minus 2 is equals to 1. So 2x is equals to 3. X is equals to 3 over 2. So this point, or this x of 3 over 2, we're going to then substitute it into f of x in order to find a point that lies on k of x. Right. So f of x, x squared, so 3 over 2 squared minus 2x, 3 over 2 minus 3. So let's take a look at this. So we have 3 over 2 squared minus 2, 3 over 2 minus 3. So this gives us minus 15 over 4. So right, this point 3 over 2 minus 15 over 4, it lies on k of x. So we can substitute that point into k of x in order to find the value of n. If we do that, y value is minus 15 over 4. This is equals to k of x is x minus 3 minus n. X is 3 over 2 minus 3 minus n. So we are very close to finding the value of n. minus 15 over 4 minus 3 over 2 plus 3 should be equals to minus n. So let me put that in my calculator. So minus 15 over 4 minus 3 over 2 plus 3 is minus 9 over 4. And this is equals to minus n. So 9 over 4 should be equals to n. So there we go. We have the value of n. We want to determine f prime of x from first principles if f of x is equals to 1 over x. So if we want to use first principles, we have f prime of x being equals to the limit as h tends to 0 of f of x plus h minus f of x, everything divided by h. So that is what we are working with there. Here we're just substituting x plus h in terms of x. Here we're just substituting f of x as it is, and we're dividing by h. Nothing hectic. So let's go ahead and substitute. So the limit as h tends to 0. So we're going to have 1 divided by x plus h. That is f of x plus h minus f of x itself, which is 1 over x, and then divided by h, right? So the limit as h tends to 0 is going to be 1 over x plus h minus 1 over x, everything divided by h, right? So let's go ahead and simplify the numerator. We're going to have the limit as h tends to 0 of, so we want to give those two terms in the numerator the same denominator. So we're going to have x plus h multiplied by x to the power x minus x plus h, right? Everything divided by h. So let's go ahead and solve that numerator even further. So x minus x, that is 0, and then we are left with minus h divided by x multiplied by x, that is x squared, and then h multiplied by x, that is plus xh, everything divided by h. Instead of dividing by h, we can multiply by 1 over h. So let's do that. So we multiplying these by 1 over h instead of just dividing by h. Should be easy to see that h and h can cancel out. If we cancel out h and h, we are left with the limit as h tends to 0 of minus 1 divided by x squared plus xh. Let's let h tend to 0. If we do that, we're going to be left with minus 1 divided by x squared. We are letting x tend to 0, and this is f prime of x. When we use first principles, we can actually test it out and see if it is correct using the power rule. So let's see. If we were to use the power rule, we would write 1 over x as x to the minus 1, of which when we derivate, we're going to get minus 1 x to the minus 2, which is the same as minus 1 divided by x squared. So we are quite convinced that what we did using first principle is correct, because we get the same answer using the power rule. That is 8.1, 5 marks. Yeah, it is a unique one. Most of the time we just have 2x squared plus 4, something very easy, but this one, it is quite unique, but still doable. Right, 8.1, let's move to 8.2. So 8.2, we want to, 8.2.1 to be specific, we want to determine dx of some square root of 4x to the 6 plus square root of 2x squared. So what can we do here? First of all, let's just simplify this and write it in a format of which we're going to be able to derivate. So dx, right? I'm still carrying that dx because I'm not derivating it. I just want to rewrite that in better way. So square root is the same as 1 over 2, right? So let me change that to 1 over 2. Let me open this bracket first, and then 4x to the power 6 under the same square root. This is the same as 4x to the power 6, everything to the power half, plus square root of 2 is square root of 2. There is nothing further we can do there. I don't think we can further simplify it to anything else, right? So dx, I'm not yet ready to derivate yet. I'm still rewriting this. So 4x to the power, not 4x, but 4 to the power half is 2. And then x to the power 6 to the power half is 3. So we have 2x to the power 3 here, plus the square root of 2x squared. I think I am now ready to derivate. When I'm ready to derivate, I'm going to then say equals 2, because now I'm derivating. How do I derivate 2x to the power 3? I'm using the power rule. So the exponent multiplies the coefficient. We get 6x, and then we subtract 1, right? That is the power rule. So 6x squared. And then plus the exponent multiplies the coefficient. So we have 2 square root of 2, and then we subtract 1. We are left with x. All right, let me check and see if I'm not making a mistake. But it all seems well. So let me see. 4x to the power 6 square roots. I get 2x to the power 3. That seems to be fine. Here I don't have to change anything. And then I derivate. 4 to the power a half is 2, x to the power 3, everything to the power a half seems to be well. That is 8.2.1. Let's take a look at 8.2.2. So 8.2.2, we want g prime of x. If g of x is equals to, let's take a look, 3x to the power 4 minus 4x squared plus 6 divided by x squared, right? So it's easy to see that we cannot take a common factor on the numerator that will cancel out this x squared, because most of the time when we have something like this, that is the approach, but it doesn't seem like it's gonna work here. But let me show you what we are gonna do, right? So g of x, we are rewriting it, right? Is equals to what do we have? 3x to the power 4 minus 4x squared plus 6 multiplied by 1 over x2, right? Let me show you something. 1 over x2, it is the same as x to the minus 2, right? So instead of 1 over x2, let's change it and write x to the minus 2. So x to the minus 2. Yeah, we can actually check if 1 over x2 is equals to x to the minus 2. We can substitute 7 on both sides. When I substitute 7 on the left hand side, I get 1 over 49. And then when I substitute 7 on the right hand side, I get 1 over 49. So that is true. So now it's just a matter of multiplying all the terms with x to the minus 2. So let's go ahead and do that. We still have g of x. We're not yet ready to derivate. So multiplying 3x to the power 4 by x to the minus 2, we're going to have 3x, and then we add the exponents, 4 and minus 2. 4 and minus 2 is plus 2. So there we go. And then a minus 4. Again, we are adding the exponents. Minus 4, not minus 4, but 2 plus minus 2 is 0. So we have x to the power 0, which is 1. So x disappears there. Well, it doesn't disappear, just cancels out. And then plus 6. We're just going to have plus 6x to the minus 2. Now I'm ready to derivate using the power rule. So g prime of x will be equals to the exponent multiplies the coefficient. We get 6x, and then we subtract 1. And then minus 4 is a constant, so the gradient of a constant is 0. We can forget about that. And then 6 multiplied by minus 2, that will be minus 12x, we subtract 1, so minus 3. Yeah, I think that is 8.2.2. How many marks? 3. And then 8.3, quite an interesting equation. Let's go ahead and take a look at it. The equation of the tangent f of x is equals to 3x squared plus bx plus c at x is equals to 1 is given by y is equals to 9x minus 9, as you can see there. Determine the values of b and c. So let's take a look and see how we can solve that problem. So we have the gradient at x is equals to minus 1 because we have the equation of the tangent. The equation of the tangent, y is equals to 9x minus 9. So this 9 is the gradient at x is equals to 1. So we can derivate f of x and equate to 9 and substitute 1. Because when x is equals to 1, the gradient is 9. We're getting that from the equation of the tangent. So if we go ahead and do that idea, f prime of x will be equals to 6x plus b. C is a constant, so it's gone. The gradient of a constant is 0. So there we go. And then at x is equals to 1, the gradient is 9. So the gradient is 9 when x is equals to 1. So 9 minus 6 is 3. So b is equals to 3. There we go. We have the value of b. So f of x at this point, we know that it is equals to 3x squared plus bx. b is 3. So plus 3x plus c, right? We know that f of x is equals to that. And then what can we do? We can substitute the point where x is equals to 1. Okay, so first of all, we need to start by saying that y is equals to 9, and then in place of x we have 1. We want the coordinate at that point, because in order to find b, we use the gradient at that point. So we can find the coordinate and use the coordinate to find c. So 9 multiplied by 1, that is 9, minus 9, that is 0. So when x is equals to 1, the y value is 0, right? And then when x is equals to 1, the gradient is 9. Yeah, those two things can be correct at the same time. There's no issue there. So if we substitute that point into f of x, we're going to have 0 being equals to 3 multiplied by 1 squared plus 3x. 3 multiplied by 1 plus c. So 0 is equals to 3 plus 3 plus c. So 3 plus 3, that is 6. So minus 6 is equals to c. So we have b and c. F of x is equals to 3x squared plus 3x minus 6. Let's see if this is correct. We can substitute x is equals to 1 and see if we're going to get 0. Yeah, we will get 0 because we got the value of c using that fact. So we should get 0. But let's just see. F at 1 is equals to 3 1 squared plus 3 1 minus 6. Okay, this is, that's fine. Maybe let's check if the gradient is 9. F prime of x is equals to 6x plus b. 6x plus b. What is b? B is 3, right? So when we substitute 1, we get 9. So the gradient seems to also be valid. Yeah, so that is the answer to 8.3. Which question do you want me to do next? Let me know in the comment section, and I'm going to do it right now. We want to show that a is equals to 1, b is equals to minus 3, and c is equals to minus 9. We're given the equation f of x is equals to ax to the power 3 plus bx squared plus cx minus 5. What we are going to use in this question is the x-intercepts. We are given E and G as the two x-intercepts of this function, right? But what is happening at E? E is an x-intercept and a turning point at the same time. That is easy to see. When that is the case, we have f of x being equals to x minus x1 squared multiplied by x minus x2. Usually we have x minus x1 multiplied by x minus x2 multiplied by x minus x3. But when you have a x-intercept that also serves as a turning point, then that intercept, you will use it as x minus x1 and then you square it again, if and only if it also serves as a turning point. So by saying that, we're going to have f of x being equals to x minus minus 1, so that is x plus 1. We square that multiplied by x minus 5, the other x-intercept. So f of x will be equals to, what is x plus 1 squared? That is x squared plus 2x plus 1. You multiply that by x minus 5. So f of x will be equals to x squared multiplied by x, that is x to the power 3. And then x squared multiplied by minus 5, that will be minus 5x squared. And then 2x multiplied by x, that is plus 2x to the power 2. And then 2x multiplied by minus 5, minus 10x. 1 multiplied by x plus x, 1 multiplied by minus 5, minus 5. So we have f of x being equals to x to the power 3. Minus 5x squared plus 2x squared is minus 3x squared. And then minus 10x plus x is minus 9x minus 5. Clearly, we can see that a is equals to 1, the coefficient of x to the power 3, and b is equals to minus 3, the coefficient of x squared, and then c is equals to minus 9, the coefficient of x. We have shown that a is equals to 1, b is equals to minus 3, and c is equals to minus 9. Right, so let's be careful of this. When we have a x-intercept that also serves as a turning point, we can use it twice. Let's go ahead and do 9.2. So 9.2, calculate the value of f for which the function f has a local minimum. So this is our local maximum and this is our local minimum. So we want the x value at that point. How are we gonna do that? Well, we know that the gradient at the turning point is 0. So it's just a matter of derivating the function and equating to 0. And then we're going to have two x values. It will be easy to see which one is for the maximum and which one is for the minimum. Because the one at the maximum, the x value should be negative, right? We already have it. We know that it is minus 1. We're just looking for the x value at the minimum. So let's go ahead and do that. F prime of x, we're derivating. We're going to get 3x squared. We're derivating this function, right? Because now we have the value of a, b, and c. So 3x squared minus, is that going to be minus 10x? Not minus 10x, but minus 6x minus 9. And then in order to find the x value at the minimum and the maximum, we equate these to 0. We can take a common factor of 3, obviously, and multiply by it on both sides. We're going to be having x squared minus 2x minus 3 being equals to 0. So let's go ahead and factorize this. 2 factors of minus 3, of which when we add we get minus 2. That is minus 3 and plus 1. Right, so x is equals to 3 or x is equals to minus 1. We know that x is equals to minus 1 at the maximum. So at the minimum, x is equals to 3. This is what we are looking for. This is the x value at the minimum. So here we have minus, here we have minus 3 at the local minimum. So right, that is how you can find the x values at the local maximum and minimum. Okay, 9.3, use the graph to determine the values of x for which the second derivative of x multiplied by f of x will be greater than 0. We're supposed to use the graph and the graph only. I'm not sure about how we can do that, but take a look at this idea. F prime of x, we know fully well that it is equals to 3x squared minus 6x minus 9. I'm getting it from here. So if we find the second derivative, we're going to have 6x minus 6. So this is the second derivative. Okay, let's find the intercepts of this second derivative. I want to find the intercepts because I want to sketch it and show you something. So let's just say y is equals to 6x minus 6. If we let x be equals to 0, y will be equals to minus 6. And then on the other side, if we let y be equals to 0, let's find out what x is going to be equals to. X is going to be equals to 1 because 6 minus 6 is 0. So x needs to be 1 there. So these are our intercepts. Let me show you what I want to do with those intercepts. So I'm going to come to a graph here and sketch that the second derivative, 6x minus 6. I know that I have an intercept somewhere here at minus 6 and somewhere here at 1. So I can go ahead and sketch my graph. Let me do that. Okay, right. Yes, my ruler, and I'm about to sketch that graph. So let me use a lighter pen, and let's see. Yeah, lighter in terms of the thickness, not in terms of the color. So this is the second derivative. If we sketch it, it looks like that. This is going to simplify our problem because we are looking for values of x for which the second derivative multiplied by f of x will be greater than 0, right? So we need both of them to be greater than 0, or we need both of them to be less than 0. One between the two, because if they're both negative and you multiply them, greater than 0. If they're both positive and you multiply them, greater than 0. So right, let's go ahead and see what that will turn out like. Okay, take a look at this. From positive 1 up until negative infinity, y is less than 0. The second derivative is less than 0. The same is true with f of x. It is also less than 0. So they're both negative, meaning that we can actually, if we multiply the two, our answer is going to be positive. So we're saying that from minus infinity to positive 1, these two functions are both negative. So our condition is satisfied. But take a look at something. At x equals to minus 1, f of x is actually equals to 0. And we need our product to be greater than 0, not greater or equals to. So let's see here that we need x to not be equals to minus 1. If x is equals to minus 1, we're going to experience some issues. So there we go. That is the first part of our solution. Let's take a look at from 1 to positive infinity. From 1 to positive infinity, it should be easy to see that from 1 to 5, y, or the second derivative, it is positive, right? But f of x is negative from 1 to 5. So one is positive, one is negative. Our condition is not satisfied. So that cannot be part of our solution. But let's take a look at from 5 to infinity. From 5 to infinity, we don't have any issues. Both of them are positive. So from 5 to infinity, our condition is satisfied. We are not including 5 because f of x is 0 when x is equals to 5. So we cannot include 5 as part of our solution because we need our product to be greater than 0 and not equals to 0. So this is our solution for 9.3. I don't know how you can deduce this without actually finding the second derivative. There's probably some technique, you can't really memorize all methods in maths, right? You just need to pick that which is, you're comfortable with and which will work all the time. So somebody can propose something else and still get the same answer, and that is totally fine. So yeah, that is 9.3. Let's go ahead and do 9.4. So in 9.4, let's take a look. For which values of t will the graph of p of x be equals to f of x plus t? Have two distinct positive roots and one negative root. We solved a problem like this a couple of years ago. I think 2 years back or 3 years back. Can't remember. I've been doing this for some time now. But let's go ahead and take a look and see what is happening here. So p of x is equals to f of x plus t. So this t is essentially shifting f of x upwards or downwards, depending on what you're trying to achieve. So we want to shift f of x such that you're going to have two distinct positive roots and one negative root. So let me show you what we can do then. Let me show you what we can do. I just need to erase all of this now, right? So that is erased, and now let me trace this function, right? You're gonna see why I'm doing this. Just let me cook. So right, there we go. So take a look at this. Right now we have one negative root which is at e, and it is -1. Well, one negative and one positive because we have positive 5 then. We need two distinct positive. We need two positive roots and one negative. So take a look at this. If we shift this graph slightly upwards, let's shift it here. You're gonna see that we have two negative and one positive. If we shift it here such that the x-intercept is at 0, we're gonna have, well, is 0 positive or negative? But we have a dilemma there. We have one negative, one at 0, and one positive. But we want two distinct positive roots. So take a look at this. If we shift it just a unit upwards, then we have one negative and two positive roots, right? The y-intercept initially on our function, it is at -5. Let me write that down. The y-intercept is at -5. That's our y-intercept. But when our y-intercept is greater than 0, then we have one negative and two positive roots. So we need to shift this graph by at least just above 5 units up for us to have one negative and two positive. So we need t to be greater than 5. If t is equals to 5, then we're gonna have one negative, one at 0, and one positive. And we want one negative and two positive distinct roots. So we need 5. We need t to be slightly greater than 5. But take a look at this. If we keep shifting it upwards, one negative, two positive, one negative, two positive, until we get to this point where we have the local minimum touching the x-axis there. If we get to that point, issues are gonna arise because we no longer have one negative and one positive. Not one negative and one positive, but one negative and two positive distinct roots. So we need to shift it by at least 5 units, but not units greater than the distance from, this minimum here and the x-axis. So we need to find the y value of that minimum, because if we shift it more than those units, then issues are going to arise. How do we find the y value of that minimum? We have the x value. We calculated it in 9.2. So we're going to say f of, I think the x value was 3. Yeah, f of 3 is equals to 3 to the power 3 plus, okay, b is -3. So -3 squared C is 9, it's minus 9, so minus 9, 3 minus 5. So let me go ahead and put that in my calculator. So 3 to the power 3 minus 3 multiplied by 3 to the power 2 minus 9 multiplied by 3 minus 5. That is minus 32. So we need t to be less than 32. If t is greater than 32, we're going to have some issues. If t is greater than 32, we're going to have some issues. Our condition is not going to be satisfied anymore. So we need t to be between minus, not between minus, but t to be between 5 and 32. If t is between 5 and 32, our conditions are satisfied. And there we go. Which video do you want me to do next? Let me know in the comments. This is a very special question. 10.1. Show that the area of EFGH is given by a of x is equals to 6x squared minus 3x to the power of 4. So let's go ahead and take a look at our question statement and see how we can potentially solve this question. So let me denote that EFGH is a rectangle, as you can clearly see, right? And then HE is produced x to the power 2 centimeters to n, and EH is produced x to the power 2 centimeters to p. So we have the distance from h to p being x squared, and the distance from e to n being x squared, and then the total distance from n to p is 4 centimeters. That's what we have, right? Let me just erase this. So that is the information we have. It goes on to say that PG is produced at M to form an isosceles triangle MNP with NM is equals to MP. So NM, this side, is equals to this side, right? So if we have K on this side, we also have K on this side, right? Some K units. Let's carry on. And then MD is parallel to NP. We have an angle of 90 degrees there that shows that clearly, right? And then what else do we have? NP is 4 centimeters. We can see that from the sketch, and MD is 3 centimeters. So maybe let's write this 3 centimeters right there, because MD is 3 centimeters. If from N to P is 4 centimeters, then from N to D is 2 centimeters. This here is 2 centimeters. Is it centimeters? Yes, it is. And then from D to P is also 2 centimeters. There we go. Let's see how we can solve this problem. We want the area of EFGH. So we know that the area it's wanted in terms of x will be equals to the length multiplied by the breadth. So do we have the length? The length will be our base. Okay, let's take a look. The length is E to H. So E to H from here at E to H. E to H will be equals to 4, the total length from N to P, minus x squared, N to E, and then minus x squared once more. So E to H will be 4 minus 2x squared. That is the length. So we have 4 minus 2x squared. So all we need now is just the breadth, and we have solved our problem. We have the area in terms of x. So let's get rid of this, and or maybe we need to include this in as part of our solution, you would think. So let's leave that there. Maybe we can put it before the actual formula for the area. Let's put it up there, right? Because how did we get the length? We need to show that. So we have our length, we just need our breadth. Let's go ahead and take a look at how we're gonna do that. So let me erase this. We have the length of EH now. We just need the length of either EF or the length of GH. Those are the two things that we need. If we get that, then we are sorted. We are good to go. we're going to use the fact that NEF is similar to triangle NDM. In what way? Let me show you. In NDM, we have these 90 degrees here, right? And then in NEF, we have this 90 right here. So we have two angles that are equal to each other. And then they share this angle. This is a common angle between the two triangles. So what can we say? We can say that triangle NEF is similar to triangle NDM. These two triangles are similar because we have three angles that are equal to each other. Two pairs are equal to each other, so the third angle is a bonus. Right, so that's what we have. Those two triangles are similar to each other. If these two triangles are similar to each other, then we can say that NE divided by ND is equals to EF divided by DM. We can see that if the two triangles are similar to each other. So let's go ahead and say that. We're saying that NE, we can just say NE divided by EF is equals to ND divided by DM, right? So what is NE? NE is x squared. What is EF? EF is B, what we are looking for, the breadth. This is equals to ND. ND is 2 centimeters and DM is 3 centimeters. So we can find the breadth. So we're going to have 2B being equals to 3x squared, right? So B is equals to 3x squared over 2. So there we go. In place of B, we can replace that with 3x squared over 2. So A, the area in terms of x, let me just copy that here. 4 minus 2x squared multiplied by 3x squared divided by 2. Right. So A of x will be equals to 4 multiplied by 3 over 2. So that is 4 multiplied by 12, which is 4 multiplied by 3, which is 12. I'm already doing the calculation in my head. And then divided by 2 should be 6. So we have 6x squared minus 2 multiplied by 3 over 2. 2 and 2 will cancel out. So we're going to have minus 3x to the power 4, because x squared multiplied by x squared will be x to the power 4. So there we go. We have the area of our rectangle EFGH. We are using the fact that the two triangles are similar and proportionality therefore. Right. I wonder if there's another way we can actually solve this question without using the mere fact that the two triangles are similar. But anyway, just let me know in the comments if you use any other alternative way. That is 10.1. Let's take a look at 10.2. So 10.2 says that let's calculate the maximum area of triangle EFGH. This is the easy equation between the two. What is hard is actually finding the area of the rectangle. After you do that, it becomes quite easy to find the maximum. We know exactly what we are going to do. We're going to derivate and we're going to equate to 0. So A prime of x, let's derivate from the get-go, will be equals to 12x. And then 3x to the power 4. If we derivate 3 multiplied by 4, that gives us 12, and then x to the power 3. So we need 12x minus 12x to the 3 to be equals to, we need that to be equals to 0. We derivate and we want to find the maximum. Alright, so how do we solve this? We can take x as a common factor. That becomes pretty much clear. Yes, we can take x, or we can take 12x. Let's take 12x as a common factor. 12x, we're going to be left with 1 minus x to the power 2 being equals to 0. So 12x is equals to 0. So here we are saying x is equals to 0, right? And then 1 minus x squared is equals to 0. So minus x squared is equals to minus 1. So we are saying that x squared is equals to 1. If you take square roots on both sides, x is equals to 1 or x is equals to minus 1. So we have two, we have 3, but let's focus on the 2. We have 2 possible answers here. X is equals to 0 and x is equals to 1 or minus 1. We can actually test it out and see which one is going to be the correct answer between these two. Let's substitute 0 into a of x. A of x will be, well, we're substituting 0, so we're going to have a of 0 being equals to 6 multiplied by 0 squared minus 3 multiplied by 0 to the power 4. Well, this will give us 0. I don't think that will be our maximum. Rather, it can be our minimum. Right, I don't think that is going to be our maximum. Okay, so when you substitute x is equals to 0, we get 0. Let's substitute x is equals to 1, which will give us the same answer as x is equals to minus 1. So when x is 1, 6 1 squared, not 619, but 6 1 squared, and then 3, x is 1, everything to the power 4. So 6 1 squared, that is 1, so we have 6 minus 1 to the power 4, that is just 1, and then we get 3 centimeter squared. So I think between these two, rather we go with x is equals to 1 or x is equals to minus 1, because when you substitute 0, we get 0. When you substitute 1, we get 3. I wonder if there's any other value that will give us more than 3. Let me know what you think about this question. I think it was very interesting, more especially 10.1. Which video shall I do next? Let me know in the comments. Here we go.